Christopher Smith, informative speech. My audience today is just going to be my wife due to my work schedule this week. My informative speech will be on how we use nuclear power to create electricity. So, as a person who has worked in nuclear power for 20 plus years now, first I started off in the Navy, operating pressurized water reactors on U.S. submarines, and now I'm in the civilian nuclear power world, where I am a licensed senior reactor operator at a boiling water reactor. I often get asked several questions. The first one is always, do you glow in the dark? And that's an entirely different speech. And the second one is usually, though, well, how do we use nuclear power to create electricity? In order to understand that, it sounds really complicated. It sounds like there's a lot of theory, and there is as far as trying to get into the nuts and bolts, but as far as the actual how it works is actually some very simple concepts. When I explain this, I usually explain it backwards in terms of I like to start at the grave and go to the cradle. In other words, I like to show this, how we get this, and then I work it back to how we use nuclear power to do that. In the United States, we use 60 hertz alternating current. So the first theory and concept we have to understand is how we generate electricity. We use the same method for most of our electricity generation here in the States, but if you look at Kemper, Jeff, and Isidore Kresenbaum, Chapter 1, Principles of Operation of Synchronous Machines, Operation and Maintenance of Large Turbo Generators, it explains the concept in great detail, but the basics is you need a magnetic field, a current carrying conductor, wire, and then you have to have some sort of relative motion between the two. In order to get that relative motion, you usually have to spin something. So the way most AC generators are created would be with a rotor, which we induce a magnetic field out by putting a voltage to it with wires wrapped around it, and then we spin it. If you look at the net generation by energy source table given out by U.S. Energy Information Administration, you can see that the vast majority of our electricity is created using a heat engine. You can use hydropower, you can use a gasoline combustion engine, you can use wind turbines, which are becoming very popular now. Anything that will rotate the rotor and give you that relative motion between the magnetic field and your current carrying conductor to push electricity down the line. So like I said, the vast majority of the US and the world for that matter, electricity is produced using what's known as a heat engine. A heat engine, when you read Weiland Gordon J. and Richard Edwin Sontag's Fundamentals of Classic Thermodynamics, is exactly what it sounds. You're going to apply heat to a medium. That medium then is going to be used to perform work. Then usually you have to get rid of that excess heat. Most of our electric production in the U.S. uses this form of mode of force, and it would be coal, natural gas. All these things are going to burn something to create heat. Nuclear power also is used to create heat. So with a heat engine, like I said, we're going to add heat to a system, usually to water, to create steam. Steam, the kinetic energy of the steam is then used to rotate a turbine, spin the turbine, which is attached to the generator rotor, which is the magnetic force, and that is also spinning, which is creating our relative motion between a magnetic field and our current carrying conductor. So that gets us to how we utilize nuclear power. So we have to have a basic understanding of the concept of what is heat. If you look up the definition of heat, and I just found it in What is Heat, the physics classroom online, heat is the measure of average molecular motion of a substance. Basically how fast the atoms are moving. If they're moving slow, it's cold. It's fast, it's hot. So how do we use nuclear fission to get us there? Nuclear fission, as described in The harnessed atom, nuclear energy, and electricity put out by the U.S. Department of Energy is when you have an atom and it separates. In the case of U.S. nuclear power reactors, we use uranium-235. It absorbs a neutron, which makes it unstable. It then vibrates and splits apart. That releases a large amount of kinetic energy. Well, if heat is the measure of the average molecular motion of something, and you just blew something apart inside of it and released all that energy, you have therefore increased the amount of heat being generated. So this heat being generated is being removed by water. It happens to be a good moderator for the nuclear fission process that we use. But it also is very nice because it turns into steam. So we do that in one of two ways. Boiling water reactor is this what it sounds like. We boil the water in the reactor. Pressurized water reactor is under high pressure. Take that heat, we move it over to a steam generator, which has got a secondary loop of water into it, and we transfer that heat to that secondary loop, and there's where we create our steam. Steam then goes down the line. It's high pressure. We take the kinetic energy of the steam, throw it against our turbine. This creates the rotational motion or the mechanical motion of the turbine into rotating. This is connected to the generator. The generator then has got a magnetic field that's being generated by applying a DC current, and it's now spinning around the end of the generator. You now have your current carrying conductors, your wires, and you now have created your motive force or your relative motion between the two, which causes the electrons to go down a line, and we get to turn on and off lights. So in a snapshot, that is how we use nuclear power to create electricity. If you want to get more in depth in this, I would highly recommend the Harnessed Atom, Nuclear Energy and Electricity by the U.S. Department of Energy. Basically because it is actually a middle school textbook, so instead of getting into all the squiggly line equations and everything that goes behind the theory, it explains the concepts really well without trying to get you way into the math and the physics behind everything. So that's how we use nuclear power to create electricity. That's the end of my speech. Thank you.